Good morning, my dear students. Now let us move on to the next topic, integration by partial fraction. Now it's given, recall that a rational function is defined as the ratio of two polynomials p of x divided by q of x, where p of x and q of x are polynomials in x and q of x is not equal to 0. That is the definition for a rational number. That is, a rational number can be expressed in the form p by q where q not equal to 0. If the degree of the numerator of polynomial p of x is less than the degree of q of x, then the rational function is called proper. Otherwise, it is called as improper. This is one of the important property. The improper rational functions can be reduced to proper rational functions by applying long division method. Thus, if p of x divided by q of x is improper, then p of x by q of x is equal to t of x plus p1 of x divided by q of x, where t of x is a polynomial in x and p1 of x divided by q of x is a proper rational function. That is, this t of x is nothing but the quotient that obtained when you divide this p of x and q of x, and this p of 1 of x is nothing but the remainder. This is one of the important thing you need to note down and go through this. Assume that when we want to evaluate integral over p of x divided by q of x into dx, where this rational it is a proper rational fraction, it is always possible to write the integrand as the sum of simple rational functions by the method called partial fraction decomposition. That is, we are going to split this new integral into simple rational functions. That's what we are going to do. For this, we have a certain format. If it is the form linear divided by a quadratic which can be factorizable. Last exercise we have seen linear function divided by a quadratic which is non-factorizable. When it is non-factorizable, then you need to apply the numerator equal to a into d by dx with the denominator term plus b. But if it is within root or within root, it may be factorizable or not factorizable. Here these terms are doesn't have root in the denominator. Therefore, if it is a factorizable quadratic form, then it can be written like this. If it is the form linear divided by a quadratic which you can factorize, that is two factors. If it is there are two factors, then you can write it as a divided by the first factor plus b divided by the second factor. A divided by x minus a plus b divided by x minus b. If you have a linear divided by a quadratic equation which is of the same two factors, if two factors are same, that is x minus a the whole square, two are there, x minus a into x minus a. Therefore, it is of the form a, it can write it to the form a divided by x minus a plus b divided by x minus a the whole square. This is the general format of whatever the function it may be. Then if it is a quadratic in the numerator, denominator should be a cubic. Therefore, if it is three different products as there, here two are there, here three factors are there. Therefore, it can be written a divided by x minus a plus b divided by x minus b plus c divided by x minus c. The next one, it's a quadratic divided by a cubic in such a way that they have given two factors are same and one factor is not same. If two factors are same, how will you write? A divided by x minus a plus b divided by x minus a the whole square. For this is over. If you have some other different factor, you will be writing c divided by x minus b. I will repeat, if you have the same factor, you will be writing a divided by x minus a plus b divided by x minus a the whole square. And for this x minus b, you are writing c divided by x minus b. And a quadratic equation divided by a cubic such that one factor is a linear, another one is a quadratic which cannot be factorized further. If it is like this, you should write a divided by x minus a plus a linear term divided by a quadratic. So only we are writing bx plus c divided by x squared plus bx plus c. It is, if it is a quadratic, if it is a non-factorizable, then you need, if it is a quadratic non-factorizable, if you have a product with one more if a factor, what one more quadratic equation which you cannot factorize further, then you need to write a divided by x minus a plus bx plus c divided by x squared plus bx plus c. According to this, you need to do the and go through the examples as well. Now let us move on to the exercise. Exercise 7.5, the first question, I equal to integral over x divided by x plus 1 divided by x plus 2 into dx. If it is like this, two different factors, so you can write this, you can split into two terms, that is a divided by, you should write the whole term and write equal to, that is equal to a divided by x plus 1 plus b divided by x plus 2. That means you are going to split this term into two different terms such that it will be easy for us to integrate. And then after that you need to take LCM to find out what is the value of a and b. Always this left hand side will be your LCM, the denominator is your LCM. Therefore, x plus 1 into x plus 2, when you take LCM of this, you will get a into x plus 2 plus b into x plus 1 divided by x plus 1 into x plus 2. Therefore, the denominator terms will get cancelled. Therefore, what you will have, x is equal to a into x plus 2 plus b into x plus 1. You can equate the coefficient of x at a constant term, but this method which I am telling will be easy for you to do. Now, equate this to 0. What you will get, x is to minus 2. So, substitute the value of x is equal to minus 2. Therefore, this term will go off. Therefore, minus 2 equal to b into minus 2 plus 1. Therefore, you will get this term. Therefore, b is nothing but, when 2 minus and minus will get cancelled, therefore, b is nothing but 2. Now, when here take a value of x to be 1, here x to be minus 1, equate this to 0, you will be getting x value to be minus 1. Therefore, you will be getting, when you substitute x value to be minus 1, this term will go off. So, minus 1 equal to a into minus 1 plus 2, that is nothing but a equal to minus 1. After that, what you are going to do is, you are going to substitute the value of a and b in this first equation. So, when you substitute x divided by x plus 1 into x plus 2 can be written as a value is minus 1 divided by x plus 1 plus b value is nothing but 2 divided by x plus 2. That's what I have written here. You substitute the value of a and substitute the value of b. Therefore, when you take LCM, we will be getting the same term. So, we are going to split this term into two different terms so that it will be easy for us to integrate. Only we are doing this partial fraction as we have done in 11th standard, we have done for one sum. So, in the place of this, in the integral, I am going to substitute this term. This is the integral, this one, x divided by x plus 1 into x plus 2 into dx can be written as minus 1 by x plus 1 plus 2 divided by x plus 2 into dx. After that, what we are going to do? We are going to take the common term outside and split the integral. That's what I have done here. Now, always keep it in mind, if you have dx by x is nothing but what? Log of modulus x. If you have dx divided by x, if there is a coefficient of x, if there is a coefficient before x, then you need to take to be t. Otherwise, directly you can write to be log of x plus 1. This what you will get, log of modulus of x plus 2. So only I have written, otherwise you can take this to be t. When you take t to be x plus 1, dt will be dx. Therefore, dt divided by t, that is nothing but log t. Log t is nothing but x plus 1. If you couldn't understand, rewind and then see. That therefore, if you have integral over dx by x is nothing but log of modulus x. If you don't have a coefficient if you have a coefficient as 1 for x, then you can write it as log of dx divided by any linear equation. Then you can write it as minus log of this one is modulus of x plus 1 plus 2 divided by 2 into log of x plus 2 plus c. Now, this can be written as, if it is a log x power n, can be written as n into log x. Therefore, this n is nothing but 2. So, you can bring it to the power. Log of modulus x plus 2 the whole square. Now, when you have log of a by b can be written as log of a minus log b. That's what we are going to do. that coefficient 2 into log of x plus 2 we are writing as log of x plus 2 the whole square, positive term I am taking, then negative term log of x plus 1 plus c. By applying the formula log of property, log of a by b can be written as log of a minus log of b. So you are getting this answer. Therefore this is the value of the integral. The next question, and one more thing I want to say that power of the numerator should be less than the power of the denominator. If not, apply long division that I told in the introduction part itself. The next question is a homework sum. Integral I equal to integral over 1 by x squared minus 9 into dx. And one more thing you need to concentrate here is whenever it is at the form a squared minus b squared, it can be written as a plus b into a minus b. In order to confuse you, definitely they will give like this. So you cannot apply. But for this sum you may have a doubt that why can't we apply x squared minus a squared formula. That also you can apply, but here this question is in concept is in partial fraction, so only we are applying partial fraction for this. So x squared minus 9 can be written as x plus 3 into x minus 3. There are two different factors, so it can be written as this is 1 divided by x squared minus 9. Therefore 1 divided by x plus 3 into x minus 3 can be written as a divided by x plus 3 plus b divided by x minus 3. After that take LCM. Instead of writing taking LCM and cancelling out the denominator, what you can do is 1 equal to, always the denominator, both the denominators will be same, so you can write directly 1 equal to a into x minus 3 plus b into x plus 3. So equal to 0, you will be getting x value to be 3. Substitute when x is equal to 3, find out what is b value, on when x is equal to minus 3, find out a value and substitute in the integral.